Which brings us to our last two questions. The American Mathematics Competition is a test sponsored by the Mathematical Association of America designed to hone problem-solving knowledge and skills. Just understand that this AMC business, this test, it's not like SAT or PSAT. You're not required to take this. This is an optional kind of test for those people that are really good at math, really interested in mathematics, and our Math Honor Society or Math Club prepares for this test. Anyway, it's not uncommon that an AMC question will invent and define a mathematical operation using some common keyboard character. Take a look at this. It uses a dollar sign here. What are you supposed to do with dollar sign? Rather than using mundane symbols like plus, minus, times, divide, the AMC might use ampersand, dollar signs, or @ symbols. As an example, you're seeing question 85. As a matter of fact, like the SAT, the old SAT used to do the same kind of thing. They've kind of steered away from that thing. However, it does crop up here on these clever questions on the AMC. All right, let's look at question 84 before 85, because 84 is supposed to sort of prepare you for 85. Use an algebraic argument to show that the quantity x minus y squared is equal to the quantity y minus x squared. The word argument in mathematics does not mean the same thing that you get into with your parents. This is proof. And it's one of the things that we focus on highly in honors geometry is arguments, mathematical arguments, proofs. To do this, expand the left side of the equation, that's this side, perform some logical algebraic rearrangement on your answer, and then factor it so that your answer resembles the right side of the equation. So this is a very basic kind of proof where you're trying to show that one side of an equation is equal to the other side of the equation. What you just do basically is you start with one side, and it really doesn't matter which side. It suggests left, so I'd go x minus y squared is equal to, and then you're going to do some math over here. Math is going to happen, and then you're going to ultimately end up with y minus x squared. And as long as you've used mathematics correctly, all of these things are supposed to be equal to each other. And this is an example of something that's called the transitive property. The transitive property goes like this. If A is equal to B and B is equal to C, then we can conclude that A must be equal to C. And a lot of proofs use this same idea. And that's exactly what you're doing here, but you're just stringing together a whole bunch more than just A, B's, and C's. So in order to make this happen, in order to figure out what this math is over here, you're going to have to expand out x minus y squared. So I talked about this in a previous video, and remember that this squared here, it's not a distributive property. Do not distribute. You only distribute if you have a 2 as a coefficient which is being multiplied. This is an exponent which tells you how many factors of this that you're supposed to multiply together. So x minus y squared, remember, is not equal to x squared minus y squared. Nope. In general, that is not the case. So what you want to do instead is rewrite this as x minus y squared, times x minus y, and then just use your foiling. First, outside, inside, last, in order to get what that expanded quadratic expression is supposed to be. And then whenever you get this, you want to try to rearrange the terms in order to make it look like this. Okay? And this question here, 84, is supposed to help you with 85. So let's look at the actual AMC question. Now, the AMC would not have given you 84. This is just our way to kind of help you through breaking down 85 into a simpler case. For real numbers A and B, and so far you only know about real numbers, not until Algebra 2 you start talking about imaginary numbers. For real numbers A and B, define a $b as being equal to a minus b quantity squared. Well, this sort of looks like what we were just talking about right over here. Okay, what is x minus y squared $y minus x squared? Whoa. All right, so in order to answer this question, what I would suggest doing is just playing around with some numbers so you can understand what this operation $sign means. So for example, let's say that I have 5 $3. Well, what that just means is that this tells you what the operation is supposed to do. It tells you to take the first one minus the second one, and then you're going to square it, which is equal to 2 squared, which is equal to 4. So 5 $3 is equal to 4 in this make-believe, made-up operation. Now, this is a much, much simpler example than what you're having to do, but it at least helps you understand what this process is supposed to, how it's supposed to proceed. So now what you want to do is incorporate the actual variable expressions. And remember over here on 85 that what you were supposed to do is show that x minus y squared is equal to y minus x squared. In other words, these two things are supposed to be equal to each other. So I'm wondering, what would you get? Remember that these two things are equal. What would you get if you did $5? Anyway, so think about those things whenever you're doing these last two problems, question 84, 85, and then I'm going to see you on the first day of school.